This is the project for the automated pipe cutter. I'm Evan Harris,
I'm Brandon Parry.
I'm Robert Baldwin.
And I'm Elijah Abraham.
and our project advisor was Mr. Bob Burns, and our academic advisor, Mr. David Loker.
So here we have our program for our Click PLC. On the left side here, we have our alarms subroutine. We have our inputs subroutine, our operations subroutine, and then our outputs subroutine. And in the main program here, we call all of those routines so the program functions correctly. To start, you can see all of our inputs here, and then our outputs. And we also have it set up for our spare inputs and outputs. Then we'll move to the alarm screen for safety, where each of our alarms are set whenever the feedbacks to the system are received or not received, depending on the condition. And all of them are reset with the alarm reset and having the original set conditions to be false. Also, all of our alarms are interlocked and then mapped back into the operations routine. So here we have our operations routine, where you have your manual mode and your automatic mode. Your automatic mode comes off of this running bit and controls all of our inputs and outputs. Here we have our VFD communication set up, and the control of when to run the VFD or when to run the conveyor motor in reverse, forward, and when to stop it. We also have our HMI tagging code, which allows a user to select a button on the HMI and keep that bit on throughout the program. We then have our feed motor code to control our stepper drive and our stepper motor and all of those conditions. And then we get into our zero counter for zeroing the first pipe. And then, depending on your selection, you will have all of these other counters to keep track of each pipe in the system. We decided to use doubles as our example, which is the 27-inch length. And here you have your conditions to count your steps for the first 3 pipes. And it will reset after each cut. And then we have our counter to keep track of the last pipe that you can get out of a 10-foot section. Once this is done, the stepper motor will be enabled to push out the waste and read the next pipe. And then at the end, we have our saw motion directions and the control for that stepper motor to bring the saw forward and back.
Taking a look at our HMI screen, we have our 3 length selection buttons with all our preset lengths. We have our alarm screen button with all of our alarms and faults for the system with a reset alarm button. We have a manual screen for full manual control of the system. That's it for the HMI. Now that we took a look at the HMI, let's take a look at the other controls on the control panel. Along with the HMI, we have our e-stop, stop button, and start button. So let's now take a look inside the panel of the automated pipe cutter. Starting at the top, we have our 3 stepper motor drives, our network switch, and our positive and negative buses. Moving down to the middle row, we have our DC motor direction relay, DC motor enable relay, emergency light relay, breakers, our 24-volt DC power supply, and our click PLC. Now moving down to the bottom row, we have our VFD, 2 motor contactors, our AC power VFD breaker, a power supply breaker, and our 2 safety relays. Now let's take a look at a live demo. The industrial automated pipe cutter has a bin that holds the CPVC and PVC pipe. From there, the pipe rotates down onto the conveyor, which then is fed into the feed rollers. From the feed rollers, it is fed into the saw, which is clamped down from a pneumatic clamp, and then cut with the miter saw, and the finished cut length is outputted at the end.